All right, here's our video for coordinate trigonometry notes. The point of this lesson is how do you find sine, cosine, tangent, and the reciprocal functions when you don't have a unit circle? So the answer is really just Pythagorean theorem to find missing triangle lengths, and then trig ratios to find the trig values. So you'll see where we have reminders of the ratios for the trig functions. Cosine of an angle theta is equal to x over r, the radius. Sine theta is equal to y over r. And what we mean by x, y, and r is, imagine you have these axes, and you've got some angle theta right here. And if we create a right triangle, and this point right here at the end of the segment, it does have, an XY ordered pair, where this is my X direction, and this is my Y direction, and this is the radius. So if you take this point right here and just extend a circle around here, then the hypotenuse is the radius. And one thing that I want you to write down here is every time we talk about R or radius in these problems, it's going to always be positive. But when we talk about X and Y, that can be positive or negative depending on which quadrant that they're located in. So write that X and Y can be positive or negative. And also remember the quadrants are labeled 1, 2, 3, and 4. So this is what we mean by X, Y, and R here. And this is basic SOHCAHTOA. This is X is adjacent over hypotenuse is a cosine. Sine is opposite Y over hypotenuse R. And then tangent is opposite over adjacent, so Y over X. And then these are our reciprocal functions that we talked about in the previous lesson. So cotangent is 1 over tan. So the reciprocal just means flipping the fraction. So y over x becomes x over y. Similarly, secant is 1 over cosine. So cosine was x over r. Secant is r over x. And then cosecant is 1 over sine. So we take the sine ratio y over r and flip it to r over y. So this section down here, we're being asked to find all 6 trig functions for the following coordinates. So we've got this ordered pair 3, 4. So I'm going to just draw this here. 3 is in the positive x direction. 4 is in the positive y direction. This would be my radius, and this is the theta that goes with those. So before I can do all of these identities, I need to know x, y, and r. So in order to find r, which is my first step, I'm going to use the Pythagorean theorem. So remember that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangles. So in this case, 3 and 4. And c is the hypotenuse, in this case, r. So I'm going to plug those values in and simplify the fraction. This gives me 9 plus 16 equals r squared. 25 equals r squared. Now from here we need to square root both sides, which technically means that r is equal to plus or minus 5. But remember that we said up here that r is going to always be positive. So in this situation, I need the positive version only. So now that I have r, I can do all 6 of my trig ratios. So sine is y over r, or 4/5. Cosine of theta is x over r, or 3/5. Tangent theta is y over x, or 4/3. And then the reciprocal functions are just flipping those. So reciprocal of sine is cosecant, which is 5/4. Cosine reciprocal is secant, 5/3, and then cotangent is 3/4. And just to be clear, I am saving, technically it's not that sine equals 4/5, it's that sine of theta equals 4/5. I'm just saving some time by not writing that every time. So I want you to pause your video and just draw the triangle for this ordered pair. All right, hopefully you came up with this. We went left -5, down -12. So this is our r, this is our theta. And we still need to find r first in this problem. So we're plugging in our x and y for a and b and r for c. This gives me 25 plus 144. This is 169. Square root both sides. 13 is r, and it needs to stay positive. So then we find our trig ratios. Sine of theta is y over r, which is -12/13. Cosine theta is x over r, or -5/13. Tangent is y over x, which is -12/-5. And notice this is a negative divided by a negative, which simplifies to a positive 12/5. Reciprocal of sine, cosecant. So this becomes 13/-12. And don't be too picky about where the negative goes. You can leave it in the bottom. This is the same as also being out front. Or the numerator. All three of these things are equivalent values wherever the negative is on the fraction. Secant is -13/5, and cotangent is 5/12. So on the back, I want you to pause your video and just read this problem and sit with it for a minute and see if you can figure out how you could get started. All right, so hopefully you've given this problem a chance. Okay, here's what's the same about this problem and the previous. We're being asked to find the value of the trig functions for this theta. What's different is I haven't been given any x, y, or r values. Kind of. Not specifically, but there is some that are implied. So right here, I have this ratio that sine of theta is equal to 5/6. And remember that the ratio for sine is y over r. So from here, I know that y equals 5 and r equals 6. Now, I want to try and draw my triangle. And y equals 5 gets me two quadrants. Quadrant 1, quadrant 2. So I either have a triangle here or a triangle here. The question is, how do I know which one? And this is an important question because when I go to find my x value, this triangle will give me a positive x value. This triangle will give me a negative x value. So that will affect the value, the sign on my ratios. So the way I figure that out is here. I have this domain restriction on theta. It's got to be between pi/2, which is here, or 3 pi/2, which is here. And so a lot of times I have students ask me, well, am I going from pi/2 to 3 pi/2 this way, which would mean keeping this triangle, or am I going this way, which would mean keeping this triangle? And my answer is, remember that by default, we travel around the circle counterclockwise. So if I'm traveling counterclockwise, I'm going to start at pi/2 and go down to 3 pi/2, which means keeping this triangle right here. So this is the quadrant that I'm going to be working in. Therefore, my x is going to need to be negative. All right. So let me erase this and get a fresh triangle going. So I'm going to be using a triangle in quadrant 2. Here's my theta. I know that y is 5 and r is 6 and this is my x. So I need to start by solving for x. So I go to my Pythagorean theorem. Now this time my a and b are x and 5. So x squared plus 5 squared equals c squared. C is the hypotenuse, which is 6, my r value. So I've got x squared plus 25 equals 36. Subtract 25 gives me 11. Square root both sides. Now technically I have positive, negative square root of 11 when I square root here. And how I drew my triangle tells me if I'm making this positive or negative. And it's got to be negative because it's in the negative x direction in this quadrant. So my x value is negative square roots of 11. So now I find my trig functions. I already know sine of theta is 5 over 6. Cosine is x over r. So my x that I found is negative rad 11 over r, which was 6. And tangent is y over x. So y is 5. X is negative rad 11. Here I need to rationalize the denominator. So times rad 11 times rad 11. You do not need to include the negative when you rationalize. So I'm going to move this negative out front of my final answer, multiply across the top and bottom, and it's negative 5 rad 11 over 11. Now I do my reciprocal functions. Reciprocal of sine is cosecant. So flip this fraction, becomes 6 over 5. Secant means flip this one, so that becomes 6 over negative rad 11. Rationalize the denominator. Don't include the negative when you're rationalizing. The negative can go out front of your final answer. And then always check if you can simplify this fraction, 6 over 11. We can't, but you do always want to check for that. Now, when you go find cotangent, do not take the reciprocal of this one. I mean, it's not wrong, but it's going to create more work. Take the reciprocal of your original ratio, because then you don't have to rationalize anything. You just have negative rad 11 over 5. If you flipped this one, you'd have to rationalize the denominator. You'd end up in the same place, but you would create more work for yourself and therefore increase the chance of making a mistake. All right, so I want you to pause the video and try this problem. All right, here is my work for this problem. Pause the video if you need to. We started out with this cosecant ratio, negative 17 over 5. We know that cosecant is r over y. We know that r is positive, which means that my y value is negative. This right here tells me that I need to be looking at the quadrant between negative 90 and 90. So negative 90 is here, positive 90 is here. We're going counterclockwise, which means starting at your minimum value, the negative 90, and going counterclockwise this way. So that's how I know I'm looking at this side of the y-axis. And then pause your video and just catch up with the rest of those notes.